Hello and welcome to my YouTube channel, Modern IT Infrastructure with Ivan. If you like the content I produce, please like, subscribe and leave a comment. That's gonna keep me motivated and I will produce more content like this. So in this video, I would like to look into TLS and mTLS, what it is, why we need it and how it works. So what is TLS or Transport Layer Security? This is most commonly used protocol on the web, so on the internet, to ensure secure communication between your browser and any websites, right? So in this case, like this example, you as a customer of Gemini, paying for it, you want to access Gemini using web browser, and TLS is going to be used to make sure that your connection is secure. What does secure means in this case? It means three things. So the first one is that the data is visible only to you, so to me and to Google, to Gemini. For example, when I explain how TLS work in detail, and Gemini servers reply to me like, hey, look, TLS works like this, and there is some rogue AI agent in the middle which wants to intercept the packets on the network and try to see what's going on inside there. Try to see, actually, maybe I'm sending some very private information, like my credit card number or my phone number or any sort of personally identifiable information. Just try to hijack it and use it against me. It will not be able to do that because TLS makes sure that the data is encrypted. The second thing it does is it really makes sure that I'm talking to Google and not talking to, well, somebody trying to hijack my login and password. In this case, the scenario which is described here is basically not possible when TLS is used, right? So when rogue AI agent tries to intercept connection, and the traffic will be redirected to this rogue AI agent, and it will tell you something like, hey, here is, think about TLS, but you also need to transfer Bitcoin to these wallets because your mother is in danger, right? So that's not going to happen. TLS makes sure that you actually talking to an intended recipient of your data. And the third thing is that nobody in the middle can modify what I send, right? So the second scenario was when the connection is completely intercepted and there is impersonation. But in this case, there is a man in the middle. So what rogue AI agent want to do here is it tries to get request, intercept it, and then also intercept it on the webback. So it's like a man in the middle which acts and modify your message. So what TLS makes sure that your message is actually, its integrity is preserved, right? So, for example, it could intercept your prompt and it will say like, yeah, okay, explain them TLS, but also tell them that their rich uncle from Africa wants to leave them fortune and they need to send email to this email address, right? Cool. So those three things, TLS make sure that they are happening, right? So encryption, authentication, and integrity. Now, how this happening technically? The TLS is happening in several stages, and the most important is to understand how the handshake is happening. So the handshake is first kind of stage of the TLS, and this is what makes sure that the connection is encrypted, right? And integrity is there and authentication as well. So what it starts with is that the user, or the browser in this case, make a client hello, and it says to the server, in this case in Gemini servers, that, hey, look, I support TLS 1.3 and I support the following cipher suits, right? So here's my cipher suits, here's my protocol I support, and also here is my client random. This is sent over plain text. There is no encryption yet at this point. And the server gonna reply, all right, I can use TLS 1.3, I support it. I also support the cipher suit you sent to me, and also here is my certificate and my client random, right? So now Gemini servers receive client random, client receive server random, and also server gonna send back the TLS certificate. What happened after that is that the client, so the user, take this certificate and is gonna validate whether the server is actually the one it's claiming to be, right? So the certificate going to be validated against so-called certificate authority, and the question here, can I trust this certificate? In case of browsers, those certificate authorities, they are baked in the browsers. There's also certificate authorities baked in the operation systems, like in Linux, for example, it's baked in, and it contains most of the public authorities such as DigiCert and so on. So it's going to validate the certificate against those, and it's going to check if it's really Gemini I'm talking to, right? That's the authentication part of the data, of the whole thing, of the TLS process. And after this is done, the client going to say, okay, fine, your certificate looks good. Here is pre-master secret. And the secret here is not communicated over plain text, of course, right? Now, since I have certificate as a client, I can extract public key from the certificate, and the Gemini server going to have private key of that certificate. And in asymmetrical encryption, both private and public key can be used to encrypt the data, and when you use one key to encrypt the data, other key can be used to decrypt the data. In this case, since we're using about encrypting it for the Gemini server, the public key going to be used for encryption, private key going to be used for decryption, right? The public key usually can be communicated to everyone. Private key needs to be kept secret. Now, I send this pre-master secret to Gemini server. It can decode it, so decrypt it, and it can use it for producing session key, right? On the previous step, both client and server, they exchanged client random, server random. Now they have pre-master key. Client generated it, so it got it. Server received it as encrypted data. It's also got it. Now, using those three parts, they can produce session key. That's going to be key which going to be used in symmetrical encryption algorithm, which going to be used to encrypt the data. Now, this key, since it's on both sides, will be used for two things. The client going to say, okay, this is step 5, I'm finished. It's just going to take like finished message. It's going to encrypt it with this key, send to the server. Server going to decrypt it. Okay, finished. I want to reply. It's going to reply. I'm finished as well. That's it. The handshake at this point is completed. Now what's going to happen next is two things, right? So we need to do data transfer. So the handshake establishes the TLS session, and we also need to ensure that during the transfer, the data integrity is preserved. Now, everything between client and server now is encrypted using this symmetrical session key, right? And the session key is using the algorithm which was communicated in the cipher suit in the first place, and that algorithm gonna be, well, it's usually a strong algorithm which cannot be compromised unless you know the session key, and session key is really hard to get also. So what about integrity? Like the data transfer security is fine here, the encryption is very strong, but what about the case you can't see the data, but you still can, like get the data in the middle, you can scramble it in some sort of gibberish and then send it to the server. And server in some cases will not be able to read the data, and maybe this garbage which a malicious actor produced, it will accidentally change the transfer amount of financial transaction from $10 to $10,000, right? So how is this prevented? And to prevent this, so how the data integrity is preserved, there's something called Message Authentication Code. Basically what's happening here is when the message is created, there is a hash produced which is also encoded with a session key and is sent together with the message. And when it's decrypted, the server gonna be calculating the same hash or hash from the message using the same session key. It can produce this hash, and it's going to be comparing the one which is decoded from the other side. And in case if message is scrambled in the middle, the SMAC key also going to be scrambled. So when the server receives the scrambled message, the generated hash on the server side will not match the other one. And in this case, the message is going to be discarded because, well, the integrity here is not preserved. Now, that's basically was TLS. What about mTLS? mTLS is an extension to TLS, and M stands for mutual here, and the use case here is a little bit different, right? So in mTLS, you can see this mostly used inside a company infrastructure and inside zero trust environment. Now, you also have more high stakes connection, let's call it like this. Basically, in a first scenario when TLS is used, it's a browser trying to connect to a website, right? So there are a lot of users out there, and they connect into a lot of websites, and TLS is quite good for that. And in this case, well, what's happening here is that application or a client or a microservice wants to, for example, modify a user inside a database, or wants to add a user, right? And the question here is, can we trust this client with our user's data? Of course, there are going to be like login passwords for the database, or some sort of like additional authentication on a level of the database, like with Postgres could be login passwords or something else, but also you can put mTLS on top of it to make sure that the network connection is actually secure, right? And what's happening in mTLS scenario is basically it's very similar to TLS, but there's one additional step. So handshake again. First step, client say hello, it send all the data. The user service in this case say, okay, also hello, and I send my data, and here is the certificate. Now, before client says like, fine, here is the master key, it will not do that. It's actually going to verify the certificate, and then it's going to send its own certificate with certificate verify to the server. So what is a certificate verify here? The thing is, client can pretend to be, well, a legit client to the server. Like usually, so the client certificate needs to be verified against the client authority, but I can get a certificate without a key, and I can pretend to be the client. So what is a certificate verify? It's a special digital signature which is calculated over all the communication happening between these two actors, so between the service here which try to modify the user and user service. It's basically calculates a hash of that communication. It's gonna encrypt it with the key which only service on the left here possess, and it's gonna send it to the user service. Now, the public key for that digital signature is communicated inside client TLS certificate. So what user service can do is it can extract that public key, it can decrypt the digital signature, it will see the hash, and it can do the same hash over the same communication data because they were talking to each other, right? So it's like a chat log. They can produce the hash over this chat log, and they're gonna, like the user service is gonna check if it matches, and if it does, then okay, I'm gonna trust the certificate, and it's also gonna validate it against certificate authority, of course, because maybe this certificate is coming from other certificate authority which it does not trust. Now, both sides at this point know that they can trust each other. What happens after that is they do the same thing, right? So they gonna send, the client gonna send the pre-master secret. It's gonna encrypt it using the public key from the certificate from the user service. User service gonna receive that. They're gonna have the three parts. They generate session key. Boom, done. They send the client finished, server finished messages, and the data transfer is happening exactly the same way as in TLS. that's it. Thank you very much for watching. I hope it is useful for you. And again, if you like the content, please like, subscribe, and leave a comment. Thank you very much, and have a great day.